Okay, we will continue. This is one of the classic questions. The question says, is point Q, which has coordinates of negative 21 and 22, is on the line, and they give us the vector equation of the line. I like to think backward. If this point on the line, that means there is a value, one value for t. If I put it here, I will get the coordinates of r will be negative 21 and 22. So if there is one value for t, gives me this here, yes, this point lies on the line. If there is no one value, that means more than one value, or no values, that means this point doesn't lie on the line. So how we check that? Let us write this. Let's write this in parametric form. X equal 1 minus 3t and y equals 4 plus 3t. X of this point is negative 21, 1 minus 3t. So let us solve for t here. T will equal, if I move this, it will be negative 22 over negative 3, so 22 over 3. Let us solve for t here. If this is the coordinates, it will be 22 equal 4 plus 3t, so 18, so t equals 6, I think. Yeah. So I wrote 1 here. Oh, yeah. So this will be 18 equals 3t, that means t equals 6. So as you see, there is no one value for t. There is more than one value for t to produce to get those two. So this point doesn't lie on the line, because if I put t equals 6 here, this will not be 21, and if I put t equal 22 over 3, this will not be 22. Okay, so if you want to check, always put parametric form, solve for t, and see if you get the same value for t. Yes, this point lies on the line, otherwise it is not. Okay, before I do the next example, there is a little thing I wanted you to know. If I have vector n, and vector n has coordinates a and b, and I need to find vector n that's perpendicular to a and b. What we know is, if those two vectors are perpendicular or normal, n dot n should equal 0. That means a, b dot two values, I don't know what they are, equal 0. Okay. What could be those two values? For example, if n equals 2, 3, we need to find m that makes 90 degree on it. So 2, 3 dot something will equal 0. If you look at it, if we change those and change this sign, let's see, so that will be negative 6 plus 6 equals 0. So this is a normal vector 2. So one of the vectors is negative 3 and 2. And or dot 3 and negative 2 will equal 0 as well, because 6 minus 6 equals 0. So in general, if you have any vector and you want to find in 2D, this is only 2D. If you have any vector and you want to find the vector that's making 90 degree with it, exchange x and y and change one sign. So for example, if I want to find the vector that's perpendicular to, I will exchange x and y, so I will make it 6 and 5. Then I change one side, either the 6 or the 5. So negative 6 over 5 and 5 will work, or 6 and negative 5 will work as well. Okay, let's say negative 4 and 7. Perpendicular to. I change 7 and 4 is good. 7, and negative 4 is good. Okay, this will help us solving the next example. I think this marker is start to fade away, so I will finish this and I will change the marker later. Alright, so next question says find the vector and parametric equation of a line that is perpendicular to this line, r equal 4 and 1 plus 5, negative 3 and 5, negative 3 and 2. Okay, sorry. Oh, no, it's s. The parameter here I call it s instead of t. It could be any variable, but s for safety is good. Passes through 5 and 6. So when we have a question like this, let us imagine how it looks like, or draw a picture that tells us. We have a line. This line passes through the point 4 and 1 and has a direction of negative 3 and 2, so negative 3 and positive 2. So this is the line. We need to find the equation of a line that passes through point 5 and 6, so 5 and 6, probably here, 5 and 6, and is perpendicular to the green line. This is 4 and 1, and this is 5 and 6. We need to find the equation of that blue line. Okay, in order to find the equation of this blue line, I need two things. One, point on the line. Do we have trouble with this? Not at all. The point is given. Now we need to find the direction vector of this line. We need to find m, the direction of this line. How can we find m? We know that these two lines are perpendicular. So the direction vector of the green line, I will do that in red. Direction vector of the green line, which is this, is perpendicular or normal to the direction vector of the blue line, right? So if I get the coordinates of m, I can find the equation. How can I get the direction of m? M is perpendicular to n. So the second thing we need is direction vector m. We know that m dot n has to equal 0. So we know n is negative 3 and 2. As I told you, therefore, m will be, we exchange x and y, so the 2 here become x, 2y here become x, and negative 3 become y. Then we change one side, so choose any sign to change. You can make this negative 2 or you can make this 3, whatever you like. So I'll make it 3. I take away the negative. I exchanged and changed the sign. This will give me vector m that is making 90 degrees with vector n. Now everything is very simple. I'm just going to use the equation of the line, r equal r sub 0. So I use the point on the line and want to find its equation. Plus, here I used s, I will use another parameter. So any letter you like. So t is good. And then we can put n and we write the equation. Okay, this is the vector equation. How we write the parametric equation? Very simple. We separate the x's and the y's. So x will equal 5 plus 2t and y will equal 6 plus 3t. instead of choosing -3, I choose to change this to -2 and have this is -2 and -3. It will be the same thing. It will be this vector, and it is also in the direction of the line. So it will be the same thing. You're gonna write here -2 and -3, and it will be the same line, so no problem. Okay, I finished what I want you to know about vector and parametric equation, and I give you examples, the main examples that can make you started. Of course, starting. I will give you homework, and of course I want you to watch these videos, watch it twice. I prefer, or if you get it completely from one time, that's fine. But you need to practice those questions, please. Page 433, number 6, 8, 10, 12, 13 is very important. And number 14. All of those are important, but 13 is very important. Okay? Thank you so much. I miss you a lot, by the way, and you are in my thoughts and my prayers.